beyond LLMs. I think the title summarizes everything about the era of generative AI disruption that we are in today, right? So there is no doubt or denying the fact that generative AI is, we are in an era of generative AI disruption. Anything and everything that we talk about today, there is at least one time in our work that we probably talk about, think about, or use generative AI for various reasons. Studies and market research also state the same. McKinsey says 72% of the companies really want to work and bring in generative AI as part of their industry, irrespective of what industry they are in. Nearly the overall investment surge or the spending on generative AI has increased drastically over the last couple of years, particularly after the advent of GPT 3.5, GPT 4, so on and so forth, right? And all the other companies joining the bandwagon. Applications, key applications in the finance, healthcare, and education industries have also shown a lot of momentum in using generative AI in whatever ways that they can use, right? So all the hype, irrespective of the hype, there is a lot of push towards using generative AI and making it applicable to day-to-day work. Having said that, it's not utopic. It's not hunky-dory. There is a lot of issues when it comes to generative AI applications. The paradox of productionizing is what I would probably call that. Generative AI applications, when it comes to implementing simple, small-scale LLMs, trying to use as chatbots, document intelligence units, they do very well. But the moment you talk about going beyond the proof of concept, scaling it up at an enterprise level, there are a lot of challenges. So which also is captured by Gartner in their studies that over 50% of the companies have problems implementing generative AI solutions in production, right? And almost, even if they succeed, the success timeline is going beyond 6 months, which kind of takes away the zeal about implementing solutions faster, right? Post-production post-POC discontinuation. There's a lot of push towards experimentation, push towards proof of concepts, push towards putting generative AI in lower environments, making user comfortable, experimentation. But the moment we talk about productionizing it beyond POC, there is always a step back. So there are challenges. Challenges at various levels, not just at the scale with which generative AI applications are being implemented, but more importantly, when the user community, the business community is coming and using generative AI, they see a lot of skeptics around the bias that generative AI can create due to its hallucinations, right? So that's an obvious factor, and Gartner had captured that as well. Increasing project abandonment. 42% of the companies that are surveyed as part of S&P Global Survey said that many of their generative AI initiatives, they plan to abandon, not because of the fact that generative AI is not capable, but because of the fact that they are probably limited in terms of scaling up to generative AI's capability. And there are so many other extraneous factors that prevent them from really implementing generative AI solutions in production, right? And last but not the least is the failure rate, which all adds up to the first 3 points that I mentioned. It all adds up to the overall failure rate of generative AI. So what can we summarize from this slide? It's easy to really talk about generative AI, implement them at a lower environment level, use them for really pepping up the leadership and the management about, hey, what is the possibility? But the moment we are stuck with reality to put them in production, things change. And when I'm talking about putting in production, I'm not talking about chatbots. I'm not talking about conversational AIs. I'm not even talking about document intelligence systems. I'm talking about having generative AI stitch itself towards an organization's workflow, right? End-to-end workflow. And that's the aspect that business communities are expecting, right? So the key is, how do we derive return on investment of generative AI, right? Let's look at a little deeper. What are some of those aspects that really prevent us from productionizing generative AI? It is not a technical issue, right? It is not an issue of organizations' wherewithal to really implement solutions. Large organizations have done repeatedly generative AI implementations, but it's not like, you come and plug and play a generative AI application and it starts making wonders, right? Like, there are so many times then people also have the thought process that if I connect my data to generative AI, my data gets automatically corrected, which is probably the foremost myths that I want to shatter right away, right? So what is the challenge? It all starts with data quality and readiness of data for generative AI. 30% of the projects fail because of bad data. There is no taking that away, irrespective of whether you're working with generative AI or discriminative AI. Data is key. If you send in garbage, generative AI is going to hallucinate and send more garbage back to you. So you've got to be very, very careful about it. Organizations are now thinking that for me to step into generative AI and really make the hype a reality, there is no way that I can escape the route of data. Earlier, at least, there used to be scenarios where, okay, I don't want AI because I need to end up building large data platforms. So discriminative AI, machine learning models need a lot of training, so I don't need to do that. But now organizations are realizing that they have to be in the generative AI bandwagon. And for them to do that, they cannot just like that enter into the bandwagon without correcting their data. So what does data correction mean? I mean, it is not just about making your data pipeline stronger, right? It is about correctness, consistency, and completeness of data, which is the core principle of every data platform, right? So that is something that's important. Scalability and performance. LLMs demand high resources. All the cloud, all the cloud leaders, Azure, AWS, GCP, while they offer a lot of connectivity through APIs, we all know that the cost of running a generative AI application, it's not going to be, just pittance. It is easy to go to the market, but to make that application work time and again, it's only going to add more cost to it, and you've got to plan for that, no other go. And your documents are not going to be simple documents that you probably use during POC. Your documents are going to change, dynamically changing. Your entity recognition processes are going to change. Redaction processes would probably come in where you need to obfuscate the data. There are so many ifs and buts that you'll have to deal with when it comes to scalability and performance. The expectation here always is during POC, if I supply 10 documents and if generative AI is able to extract whatever entities that I want from the 10 documents, my generative AI is good for production. That's never the case. Because in production, you're going to have so many different types of documents, so many different types of requirements, rules change, methodologies change, document types change. So it is going to be important that you think through all of that ahead of the curve before, even during the proof of concept, right? Don't think that proof of concepts that are done within six weeks' time are good enough to really make your generative AI applications put in production. It is not the technical feasibility. It is the thought process and the business nuances that need to be considered, right? Integration complexity. And this is a key element that prevents generative AI applications to really reach production scale. What do I mean by integration capability? Is not about API orchestrations. It is about, let's say your organization runs on SAP or Salesforce or any ERP system, right? How do you make sure that the only way that you can make business out of whatever tech stack that you have is making sure that your generative AI is able to use the data that particular business application renders and able to probably give insights and whatnot. So the expectation that you would have is your generative AI looks into it, connects to Salesforce, connects to SAP or any other ERP platform, extracts the information, whether it is unstructured or structured, and be able to go and generate insights. Is that something that is doable right away? Not at all, right? It's not. Your generative AI applications, large language models are still very document friendly. While there are opportunities that have changed, systems like RAG has come in to really start looking at a little bit of structured data. It's not that easy, right? So integration is the key. The problem is when we talk about ROI, we fail to realize the capability of generative AI applications to seamlessly integrate with your business operating systems. When I say business operating systems, you can think of any enterprise scale system like ServiceNow, Salesforce, SAP, whatnot, right? And that is a very, very important aspect for making generative AI work for you in production. Standalone applications, let's say you just have an application that reads a document, spits out some insights, be able to extract entities, send some insights to the users. That is possible. I'm not even talking about that as a challenge. I'm talking about taking it to the next level where that particular application, what more can it do? Are you really putting that application to its fullest use? And that is the key that we are looking at. Reliability and hallucinations. I think we've talked enough about hallucination that it's a cliche now, right? But it cannot be ignored. And the more type of data that you bring in, the more hallucinations that you would probably see. I recently was writing a code a week back using LangChain to connect to my Postgres database, trying to ask a question, asking a simple select query, right? It's all select all the columns from the table, right? LangChain went in, look, it was basically an agentic process that I put in. It went in, it was able to go and get the information, but it had to retry 4 times before it just understood what is select star from table is, right? So I had to change my prompt a few times to make it understand that extract all the columns. So my prompting is probably the key there, right? So there are so many different aspects when it comes to hallucination, and we have to understand that hallucinations cannot be controlled. It can probably only be ring-fenced to a certain extent, but you will have to be prepared for monitoring the hallucinations effectively, right? So that is a key. Cost, obviously, don't need to that resource cost, integration cost, all of this needs to be looked at. Very quickly, we put generative AI into, let's say, production, and then every day the cloud costs start hitting you. You start having smaller heart attacks, right? So you'll have to be very, very careful about it. Tokenization, optimization has to be thought through before even you put a generative AI application into production. What do I mean by tokenization? You are thinking of testing your generative AI with a document with 10 pages, but in production, if you hit a document with 100 pages, you've got to really scale up the tokenization process at that level and scaling it. And if you write a very simple standard prompt saying, go and get all the entities from the document, your token optimization is going to suck. So you've got to be really careful about thinking through the process as to what would be your future documents that would be added to generative AI. And that is part of the cost that we are thinking about. Security and compliance. And this is a key. And the aspect of security and compliance is not just about privacy, right? Many a times, I think we have come to a stage where data privacy can be managed, can be addressed. There are issues, but that can be definitely managed. A lot of topics like threat intelligence and cybersecurity attacks and honeypot systems can definitely be built. But what I'm talking about is security and compliance that are caused because of bias, right? With machine learning models, deep learning models, there is a certain amount of explainability that I can actually encourage. I can probably add some level of Python code, bring in packages like Lime, Sharp to actually understand what is failing in the machine learning models. But generative AI models are black box. I don't even know what's happening unless they probably tell me that this has happened. Think of this as most post-mortem effect that's happening on my query, right? Rather than preemptive approaches. So security and compliance is not just about data privacy. It's about bias. I need to be very, very careful about making sure that my content moderation strategies are well beyond the default strategies that generative AI has. Every single generative AI API knows how to filter profanity, how to filter unethical text, but you need to go beyond and probably curtail it to your own organization regulations, right? And that is probably going to be going to be brought in from a security and compliance standpoint. Lack of transparency. Obviously, explainability of generative AI is not easy unless and otherwise you take pains to really build an explainable model. And that's going to be a key aspect of putting generative AI applications into production. So standalone LLM applications cannot always make the cut into production unless and otherwise you are dedicatedly looking into it, adding all the bells and whistles that you need to add. So what is the need of the hour? I'm not going to say that Agentic AI is going to come in and cut out all the problems that generative AI have. Neither am I going to say that just plug in an Agentic AI and it will solve all the problems. But it is a step towards the future, right? That's what I'm going to talk about. We need a scalable, comprehensive AI-powered decision system. What do I mean by that is, build an AI system for your workflow, not for part of your workflow. Think about how the output of an AI process really impacts your overall workflow, rather than just thinking about impacting just that specific part of a workflow, right? So that's going to be the key. We need to also think about seamlessly integrating with enterprise solutions. Before even you put in a generative AI application, for the sake of putting it, make sure how that application is going to integrate with your business operating system, right? At least think about it, talk about it, brainstorm, come out with issues and concerns, discuss them beforehand. Systems that allows for user in the loop. And this is something that is automatically forgotten even during the machine learning, deep learning days. And with generative AI, this becomes a little more possible because all generative AI models are built with user in the loop process. You go to ChatGPT, Gemini, it asks you for a thumbs up or a thumbs down. What happens? It's all reinforcement learning, human feedback loop, RLHF, right? So that's the whole concept that every single generative AI model works on. So introduce that user in the loop process in your workflow, not just for the process that generative AI is really building, right? Process that can help fine-tune your AI applications. Think about when in your workflow, don't think about just using one generative AI for your entire workflow process. Think about saying, do I need a foundational model here? Do I need a light model here? Do I need to probably cut it down? And do I even need a model here? Right? So those are the questions that you probably need to ask before even, you can really think about application. So fine-tuning a generative AI does not mean fine-tuning your ML model. It means moving away from regular prompting to advanced prompting and to probably bring in aspects like retrieval augmented generation into the overall process. And if all three fail, then probably you have, fine-tuning your foundational model through fine-tuning processes like quantization and whatnot, right? Systems that not only provide insights, but are biased towards action. The bias here is used in a positive word. What I'm saying is, do not just use generative AI for insights. I think we all know it is capable of doing it. Use it for actions. What next? How are the insights going to be used? Or is the generative AI at least giving you a plan of how to use the actions, right? So that is the key with which you should probably build generative AI applications, and that is a key. So with all of this, what is probably an approach that you probably need? You cannot just go with usual approach of building a web application that can work on one LLM. You might probably need a sophisticated approach, and that's where agentic AIs come in play. So what are agentic AIs? Think of them as moving from reactive systems to proactive systems, right? What do I mean by that? Generative AI explains, gives insights, making the insights work for you, right? That is being proactive. Taking actions is being proactive. Help in autonomous action without human intervention as much as possible, wherever possible, right? So that is another aspect. So what are the key capabilities of agentic AI? Autonomy, that is what we are looking at. When a password fails, right? I'm just giving password as an example, but think of a larger workflow that compliance risk or whatnot, right? When a compliance issue happens, can a generative AI identify that it's a compliance issue? If so, if it has identified, can it go to the next step of really going to the database, update that particular transaction is a compliant failure, compliant violation? Can it go and update the reports? Can it go and send emails to the stakeholders? That is where we are talking about autonomy. Second is reasoning. Large language models are capable of reasoning, but are we using reasoning for just taking insights, or are we using reasoning towards a view towards taking actions? Use reasoning for the capability of taking actions as well. So that is where reasoning comes in play. Planning. Agentic AIs are not just capable of taking data and give insights. They are capable of planning for you. Obviously, all of this needs a certain amount of prompt engineering. But the ability of an agent to go beyond the regular capabilities of a generative AI is what comes out through planning. Again, this is where reasoning agents or reasoning models will become like your DeepSeek R1, OpenAI Deep Research, Gemini Deep Research. They come in play in helping you in planning the whole process, right? So that's a great way to actually use agentic AIs. And adaptability, being able to adapt to your intrinsic systems, your organization systems, being able to use your organization's data, make the agent work for you and your own organization. Agentic AI can really do that well. Goal-oriented, both short-term goals as well as long-term goals. What do I mean by short-term goals? You put an LLM application in a complete workflow process where you are actually doing an ERP system, purchase management. An LLM can probably look at a supplier document and then say whether this supplier suits and fits into your overarching demands of needing a supplier. But an agentic AI can go beyond and say, I looked at all the prior supplier transactions that this particular supplier had brought in. With the new rules that we have brought in, this supplier may not fit into the goal. So don't use this supplier now. Go back to them, ask them to change their modus operandi towards us, and then start using the supplier, right? So that is probably where an agentic AI will come in play. Very clearly, and that is being very focused on the goal, both short-term and long-term. And finally, integration and, that was supposed to be integration and interaction. Workflow-level interactions and using different LLM models for different reasons can be a very important aspect or a key capability of a agentic AI process. So what are the core components? Large language models, because primarily they are the ones that drive the understanding of a user query, going and analyzing the data to a certain extent, do some basic level of reasoning, and then give some insights. Then large retrieval models. This can also be thought as large reasoning models. I'll talk about it in a little bit. and then large action models. So these are three major components of any agentic AI process, right? So let us look at a little closer what large language models do in the aspect of agentic AI. The first and foremost is understanding the user query and doing base level of reasoning. So if the user is asking a question, make sure that can you flag this compliant transaction if the transaction is violating the compliance laws, right? Understanding that query needs certain amount of reasoning, right? So large language model will take up that initial job. Maybe you don't need a foundational model for this. You might need a light model for this to really understand the query, right? And then what it does is it interprets the user intent, make sure that it generates a certain set of reasons or its understanding, and then gives you, communicates the result. So essentially, think of this as when you use ChatGPT 3.5 or ChatGPT 4 or even Gemini 2.0 or 2.5, you don't actually see the steps of reasoning after you write the query. You just get a result, right? And that's what these large language models do. Reasoning gets adapted into the overall process to a certain extent. Then comes your large retrieval models. These are the ones that really help you towards making and succeeding, making your generative AI work for your organization. What do I mean by that? See, when you actually put generative AI to work in your organization for your organization's data, how do you even know that the generative AI is actually bringing in factual information, right? So for example, in the first two slides, I called out what McKinsey did. I called out what Gartner did. I tried finding and searching for reports through multiple systems, and Perplexity got me very clear data evidences about McKinsey, giving me workable links, right? And that is what I mean by grounding. So being able to get factual information from your own organization's data is going to be very, very key for you to make your generative model works, right? So from that standpoint, systems like RAG, Retrieval Augmented Generation, being able to make sure that your generative AI model looks at your own data as opposed to going and fetching data from the universe of information that it got trained on is going to be very, very key for large retrieval models. And this is where what generative AI does, it translates the user query, puts all your organization's data into a vector store, combines the context of the user query along with the vector store context, and sends it to the LLM for LLM to enhance the reasoning based on the data that it actually found from your own organization. So the concept of grounding is super important because you are making the AI not just go and select information from its universe, like finding a needle in a haystack, which it does very good, but being able to make that needle your own organization's needle, right? So that's going to be the key here. And what does large action models do? With the information from large language models for basic reasoning, with enhanced reasoning from large retrieval models, you combine both of that, send it back to a large action model. The large action model is essentially another LLM, which is focused on making actions. Now, what this LLM does is it takes the grounded information from the large retrieval model, it combines that with your user context, make sure that the context and the grounded information are all put together and validated, evaluated, and then actions are taken. So think of this, I'll go through a compliance use case. Think of this as being able to understand the user query for compliance violation, being able to go and check the company rules and the database for compliance violation against the LLM outputs, and then being able to go and connect to a company database and then say, go and flag this compliance as violated, right? So that is where large action models come in play. In every step of the way, there are limitations. And I'm not saying this is going to be hunky-dory. Remember, these are all built on models, and models tend to hallucinate. But being able to say that I've just put one process versus I've put many models in the chain, and then being able to control the hallucination at every level gives you the overall advantage of controlling the overall hallucination of the workflow itself, right? And that's where Agentic AI core components really shine. So how do they work? At a very, very high level, your large language model receives a goal or a user query, understands the context, and plans the next step at a very, very high level, 4 or 5 steps. That is what you will see. You go to Gemini Deep Research, it would, if you go and fire a query, it would create a plan, ask you whether you are okay with the plan, right? You go to ChatGPT 01, it will create a plan, ask whether you are okay with the plan. Once it gets an input from you, which is basically the user in the loop, it takes that plan, really balloons it at various levels for it to give you an output for the entire research that you are intending to see, right? And that is where large retrieval model comes in. What it does, by understanding the user query, It goes, gets all the information grounded from your own databases and say, hey, I know you are probably trying to find GDPR compliance. In addition to GDPR compliance, I want to see what are the added regulations that we have in the organization that are tied to the GDPR compliance, right? And go and get that information. And that's where large retrieval models come in. And for that, you will probably need a larger reasoning prompting methodology, like chain of thought, tree of thought, self-consistency prompting, response and rephrase prompting. Chain of draft is a new prompting that is being talked about. A lot of these prompting methodologies really help in enhanced reasoning, right? And large action models are basically execution units for the work or the knowledge that has been handed over by the LLMs and the LRMs here, right? So what does it overcome? It definitely overcomes the amount of hallucinations that a typical generative AI model can bring in. Why? Because the steps are modular. I know at what level of hallucination each step is doing, so I can do a little bit of more control, right? So that is the overall thought process. Second, it addresses knowledge gaps. We have to remember that LLM models work on a context window. If some of you had probably, almost all of you have probably written, knowledge written code, you would know that a model cannot have long-standing or long-range knowledge. Memory is important. So that is the key behind these LRM and agentic AI work as well. So obviously, it addresses many of the limitations that generative AI models have. So let us very quickly look at one use case of compliance management, and then there is already a timeout. I thought I will probably get 5 more minutes, but anyway, compliance query intake. What happens? Query intake runs through an assimilation process. The LRM goes and checks RAG, which is basically company's own database. Semantic search allows you for fast search for matching results. And then reasoning and chain of thought, second level of reasoning, enhanced reasoning comes in, and then large action model starts acting on it, right? So compliance, which is probably something, a workflow-based system, can be handled effectively by a agentic AI process itself, right? So similar to this, there are very many use cases from the healthcare side as well. For want of time, I'm going to skip this slide. But what are some of the frameworks? And I'll just introduce this and stop. React is a very powerful framework that allows you for reasoning and action. LangChain, which is an open source toolkit, allows and is built on React framework, allows you for, I was talking to you about querying a database using a natural language. React framework works, and depending on the way you write your prompts, it really gives you great results. Number one. AutoGPT is another good framework to be used. Crew AI and Llama Index. Crew AI is used for multi-agent systems, not just single-agent platforms as well. Obviously, all your cloud partners, cloud systems have huge scalable solutions that can really make you use not just single-agent systems, but multi-agent systems as well. So do agentic AI have limitations? A lot, right? Every single limitation that you probably see with Gen AI can also be there, but can be controlled, right? So we need to understand that. Ability to modularize the problem into smaller chunks and then solve them at every level allows your agentic AI solutions to really work well over a period of time, right? So security, error propagation, lack of control, this all will be there with agentic AI, but the ability for you to control is like, think of this as in a distributed platform running with microservices versus a monolithic system. Right? How effective microservices would be is what agentic AIs are going to give you when it comes to large language models and large reasoning models. So, from an implementation strategy, what are the things that we need to look at? Agent orchestration. Think about bringing in orchestration layers like AutoGen, Crew AI, which can really look at the end-to-end workflow and help in reflection. Reflection is AI looking at its own output and being able to really respond to that, right? So that is where reflections are, and these are inculcated within the agentic operation as well. Knowledge-based retrieval, action space. These are where your tools and APIs come in, right? Python has a package called REPL, which allows you to go and call for database connections and whatnot, right? So similarly, action space will bring you all the tools that can be built as part of your agentic AI. Memory management for a workflow, depending on the workflow, long context versus short context. If you want the entire workflow to be shared and the context to be shared across the workflow, you can think about bringing in such kind of models as well, right? So that is where perception module. how is your input coming in? How is your output going out? Is your input static or streaming? So allowing your AI to perceive the way the input comes in and moderate its operations. That is where perception module comes in. And output and communication layer is how you convert your output into JSON or whatever format and then appropriately move forward, right? So that is from an implementation and the strategy standpoint, these are some of the base steps. Single agent systems are very nicely working these days. Multi-agent systems are still a struggle, but platforms like Microsoft AutoGen, Crew AI, they are really allowing you to push the boundaries a little bit more, right? So new concepts, I would just call out one concept, watch for that. MCP, Model Context Protocol, is one of the latest and the greatest that's being discussed, readily implemented as experiments. And this will take the interoperability issues that LLM has or generative AI has across and remove many of that, right? Think of Model Context Protocol as like any other .NET framework or software development framework that you may have, but more focused on making sure that the context is shared across the entire workflow. Like, for example, if I talk about risk assessment or risk violation, rather than just focusing on risk violation at just one piece of my workflow, have the LLM understand the context and share it across the entire workflow so that from the beginning till the end, the context is understood and the agent is always, and all the agents are focused on that goal of identifying violation at every level, right? So those are some of the new concepts. I know I ran out of time, but thank you again.